welcome to our channel. So today we will be continuing our discussion. We will be discussing today numerical problems from the chapter machines. These numericals have been taken from constant physics book ICC class 10. Okay, so let us see what does the first problem says. It says that there is a figure given. It says that the figure shows an uniform meter rule of weight W supported on a fulcrum at 60 centimeter mark as shown in the figure. By applying, it has been kept at this horizontal position by applying an effort E at 90 centimeter mark. So it's at the 90 centimeter mark. So first of all, you have to answer that whether the weight of the rule is greater than, lesser than, or equal to the effort applied, and you have to give proper reason for our answer. Okay, so let us come to the solution number 1. Okay, so solution number 1 for this. So coming to the first part of the problem, what does the first part says? That whether the effort is greater than, lesser than, or equal than the weight of the rule. Okay, so as we know, although this is a problem from machine, actually we will be using the principle of moments. We know that under equilibrium condition, if this is an equilibrium condition shown in the figure, the rule is at a horizontal position, and we know that under equilibrium condition, the total anti-clockwise moment and total clockwise moment are equal. Okay, so first of all, let us see, if we consider the weight of the rule, it is actually acting to the midpoint. So if I just consider this figure, the weight of this rule is acting through this point. So this is the W, weight of the rule. Okay, so due to the weight of the rule, a anti-clockwise moment is being created, and the effort creates a clockwise moment. So first of all, let us see what is the anti-clockwise moment. We are denoting anti-clockwise moment by ACW. Anti-clockwise moment due to weight of the rule. Due to weight of rule. What is the value? The force is W, and the distance is 60 minus 50. This is the distance. So it turns out to be 10 W. Let us take the weight of the rule to be in. Okay, so no unit has been given. If you can consider it as Newton. Okay, no problem. So Newton centimeter. Okay, so Newton centimeter. Fine. Now the clockwise moment created due to the effort. So the clockwise moment due to effort is how much? It is effort is given E, and the distance is 90 minus 60, so 30 into E Newton centimeter. Okay, fine. Now under equilibrium condition, by principle of moments, so by principle of moments, what we can say, that anti-clockwise and clockwise moments are equal. So we can write 10 W is equals to 30 E, isn't it? Okay, so it has been asked in the question, state with reason whether the weight is greater than. Okay, so we can write this equation in this way. This implies that W by E is equals to 30 by 10, that is equals to 3 by 1. Therefore we can say that W is equals to 3 into E. So definitely the weight of the rule is 3 times the effort applied. So our weight W will be greater than the effort E applied. Okay, so this is the first part of the solution. Fine. Now what is the second question? Says find the mechanical advantage in athletics. You know that mechanical advantage, what is the value of the mechanical advantage? Mechanical advantage, you know that for a machine, mechanical advantage is given by the formula. Equals to load by effort. Okay, so load by effort. So which is here the load? Can you just guess which is the load? Obviously the weight of the rule is actually the load acting here. So here load is equal to, so just let me write it, load by effort. Okay, so here the load is actually the W. Okay, and the effort is actually the E. Okay, so E. Now then what will be the mechanical advantage? So clearly mechanical advantage will be equals to W by E. Now weight is 3 times the effort. 3 times the effort by E. Now this cancels out and this becomes 3. So obviously the mechanical advantage given in the question is 3. So this machine is having a mechanical advantage of 3 in case of idle case. Okay. So I think the solution is clear to all of you. Okay. So now let us quickly move on to the second problem. What is the second problem all about? Okay. So coming to solution number 2. Okay. So what does the second question says? Pair of scissors is used to cut a piece of cloth by keeping it a distance of 8 cm from its rivet. So actually the cloth is the load for the scissor. Where has it been kept? It is kept 8 cm from the rivet. Fine. And an effort of 10 kgf is applied at by the fingers at distance of 2 cm from the rivet. So effort is being applied at the distance of 2 cm, isn't it? So scissor, I can regard scissor as a lever. It's a class 1 lever. Okay, so for lever, we can say that the value of mechanical advantage. Okay, so just let us write the given informations. So here it has been said that the piece of cloth is kept at a distance of 8 cm from the rivet. This means that the load arm given is the load arm is 8 centimeter. Load arm, denoted in short as LA, is equal to 8 centimeter. Now the effort arm is the distance where the effort has been applied and where the fulcrum is. So effort arm is 2 centimeter. As you can see, effort arm is 2 centimeter. Okay, so effort arm is 2 centimeter. Fine. Here it is said that the effort of 10 kg, effort is applied by the fingers at a distance of 2 centimeter. So effort is 2 centimeter, and the effort that has been applied is 10 kg. So effort has been applied as 10 kg. So effort has been applied as 10 kg. Effort is denoted by the letter E. So this is 10 kg. Okay. Now, what else has been given? Anything else? No. So to first of all find out the mechanical advantage of the scissor. So we know that for a lever, the scissor is a, as I have said, is a class 1 lever. So for a lever, mechanical advantage can be given by the formula. In general, mechanical advantage is load by effort. So L by E, and for levers it is equal to the ratio of effort arm to load arm. This is also applicable. So here effort arm and load arm are given, so you can calculate the mechanical advantage as this implies that mechanical advantage is equal to effort arm means 2. Fine. Load arm means 8. So both are centimeter, no need to give unit. So it's 1 by 4. Okay. Or if I convert it into decimal, it is 0.25. Okay. So this is the mechanical advantage. Now the second part of the problem says that what is the load offered by the cloth. Okay. Load offered by the cloth. So this is the part 1. This is part 1. Okay. Part 2 is the load offered by the cloth. So again, we know that mechanical advantage is equal to load by effort, isn't it? So what is the mechanical advantage? 1 by 4. What is the load? We have to find it out. What is the effort applied? Effort applied is 10 kg. Effort applied is 10 kg. Hence, this implies that load is equal to 10 by 4 10 by 4, that is equals to 2.5 kgA. Okay, so the load is only 2.5 kg. Fine. And the third part of the problem says that whether this pair of scissor is a force multiplier or a speed multiplier, isn't it? The third part of the problem says that whether it is a force multiplier or speed multiplier. So how can you decide that? Check out the value of the mechanical advantage. The mechanical advantage, the value of the mechanical advantage, what is it? It is 0.25, isn't it? So 0.25 is less than 1. Since the mechanical advantage is less than 1, since the mechanical advantage is less than 1, therefore this scissor acts as a speed multiplier. That is, it will help to cut the cloth at a faster rate. So this is the main function of the scissor here. Okay, so this is the function. Clear? So this is the solution. Okay, so I think both the problems are clear to all of you. These are simple numerical problems but quite important, so please be clear with the concepts. We will be again coming up with a new video. Till then, goodbye.